Hello, everyone. We're starting our second session with Lucas Levy from StarkWare. He's one of the wonderful developer advocates, and we'll be today running a Cairo 101. So we had our first session with Ellie, learning about what Starks are. We'd love to learn how we can deploy a contract. For today's session, it'll be more so about learning how to deploy a contract. And we'll go through a couple of exercises with Lucas, and people should be able to raise questions. And so we'll have sessions where we'll pause a little bit and ask people to if they have any questions during the session. So it'll be more interactive. So yeah, happy to have everyone. And I'll let Lucas to introduce himself. And again, thank you a lot for having take your time and let everyone over here to learn more about Starknet and also Cairo. And I want to thank everyone. We have about 60 above people joining in to learn about it. And thanks for everyone. We'll have about 1 hour session today. So let's start thinking.
Hi, Kuno. Thanks. Hi, everyone. Thanks for having me here. Today, we'll have the Cairo 101 workshop, which is like an introduction to Cairo. Here, you'll read Cairo and you'll interact with the smart contracts. It's a great introduction to Starknet. You have to start somewhere. And then there are more workshops where you will have to write code, deploy contracts, and everything. So if you have questions during the workshop, please do ask them. I will stop to answer them, and we will have like questions after I explain the Cairo 101. So let's start. So I'm from the StarkWare developer advocate team, and we have a GitHub organization which has a bunch of tutorials. Those are the most popular. And this one is just an introduction to Cairo, as I said. And this one, you will need to write code. This one is more about unit testing, but this one you'll need to write code. This one you'll need to read code. And so we're gonna do the Cairo 101, and I'm gonna explain how it works. So basically, this is the repo, and there are like a bunch of exercises, 13 in total, and they are automatically corrected by a smart contract. And it will mint tokens which represent points. So every exercise, you can validate them and you can have points. And so to validate them, you just have to reach these two instructions: validate exercise and distribute points. And to reach these instructions, you need to read the code to understand how it works, and then interact with the smart contracts through Voyager. You can also interact through the Starknet CLI, but for an introduction, it's really easier to have a UI and everything. So first, you will need a wallet. You can either have Argent X, which is this wallet, or you can have Bravos. So you will need to deploy an account, because in Starknet we have account abstraction, which means that every account is a smart contract. So you'll need to deploy it. This will take a few minutes for the transaction to be mined, and then you will need to have ETH, because fees are now mandatory on Starknet. And the faucet, I think, is broken. We'll try, but I think that it's broken. Yeah, it is. So you'll have the full Starknet experience, meaning that you will have to bridge ETH from L1. There's not that many faucets on Girly, but you can check the paradigm faucets here. I'll drop the link here. I don't know if you guys have access to it. Then you'll just have to enter your L1 address. It will send you ETH, and then you'll have to go to Starkgate here. And you log in through MetaMask, you log in through ArgentX, and then you specify the amount you want to bridge. So let's say 0.1 ETH. Transfer, then you will have to sign the transaction. And then you will have to wait 10 block confirmation so that your account is credited on L2. I already did that, so I already have ETH on my L2, and so we can go on the exercise. So as I said, your goal is to reach these instructions. So in order to reach these instructions, it's pretty easy. You just have to call this function, which is external. It's basically like a public function in Solidity. So you can call it from Voyager, and you have the links in the README here. You have the link to Voyager. You want to go in write contract because you want to invoke functions. Basically, you can either call a function, which is a view, like it basically just returns a value. And here you can invoke a function which will modify the state of the contract. So you have to log in through your accounts. Here I will use Bravos because usually we use Argent and I want to change. So let's try with Bravos. I have ETH. Okay, so I'll just claim my points here. It has to compute the fees. I sign the transaction. And then I have my transaction hash. We can check the transaction on Voyager, but recently it's a bit slow. So we can also check on the feeder, which is a StarkWare API here. And then we've got the status of the transaction. So there are several statuses. Received, this means that the sequencer has received the transaction and that it still has to be processed. Then there is the status pending, which means that the transaction is included in a block, but the block is not mined yet. When this transaction is pending, it won't revert. It's impossible for a transaction to be discarded after it's in pending state. Then there is the accepted on L2, which means that the block has been mined. And there is accepted on L1, which means that the transaction has been, the block has been proven and posted on L1. This is the link of the feeder, but you can have it in the README somewhere. Somewhere around here. Yeah, you can have it here in the counting your points. There, you just have to add your transaction hash here at the end, and it will give you like the state in real time. And here my transaction has been mined, and we're gonna check if I have some points. So here I don't have the token added to Bravos. So to check my my progression, I have to check my balance of ERC20 because the points are ERC20s, as I said. And so I'm just gonna take the address here and add a token here, which is the name, the symbol, the decimals, and I have 0. I have 2 points. Okay, so I managed to do the first exercise. I think that's just sitting on your side for the camera to be smaller. Okay. So now we've done the first exercise, which is really easy, and we're gonna check the second one. So there is a little summary of what you will learn and what you'll have to do. Here, you'll have to use the claim points function to have the points. Here, this is the claim points. Okay, so what does it do? It takes a value as an argument. So I have to enter a value. Okay, it gets my address. It gets a secret value from the storage. Okay, interesting. And here it asserts that the value I entered is the same as the one in the contract. And then it gets my points if we manage to go here. Okay, so let's check what's my secret value. My secret value storage. So storage var decorator. So this is a storage variable. So a state variable like in Ethereum. And it just returns a failed. So basically it's just an integer. Okay, here it's a view. Okay, what does it do? It returns the secret value. Okay, so basically we just have to call this view. We'll get the secret value and then we can input it here and this should work. So let's try. Let's try here. Let's try. Okay. So what do I have to do? We have to call my secret value. Okay, so this is the secret value. I think it's the zoom thing that I can't move away. Okay, so this is the secret value. And so here we input the secret value. Same thing, bravos, wait for the fees to get estimated, sign, transaction hash, boom, feeder. Here we go. We have the transaction has been received. And so now we're just hoping for the best. So far, have you? Do you guys have questions?
Feel free to raise hand. I'll allow people to talk if anyone has questions and want to talk to Lucas directly.
So felt is data. Okay, good question. Felt, what is it? So a felt is basically a field element, which is an integer modulo a big prime, which is 2 to the 252 plus 17 times 2 to the power of something plus something. Basically, it's just a big prime, and everything is modulo this prime, and a felt is an integer. And Cairo only deals with felts. There's no string, there's no, there's nothing else. There's felt and felt pointers. You can have structs. A struct is basically like in Ethereum, a small data structure. I don't know if there's any here. Probably here. Yeah, for example, uint 256 is also a struct. You can have it here. Can come here. Uint, and here. Okay, so here is a struct, and so uint 256 has to be a struct because felts are on 252 bits, and 200 and uint 256 are in 256 bits. So you have to separate it in two felts. There are also pointers. Basically, a pointer is something that points to a memory cell. Hash built-in is a struct. Don't know if I can find it here. Yeah, hash built-in is this. It's also a struct of 3 felts. Is there an online editor for Cairo Starknet? Yes, there is. There is Remix, which integrated Starknet and is currently upgrading the plugin So it works better because for now, here I can add Starknet. For now, I think that it's just, if there is an error, it doesn't tell the error. Like here, if I input random stuff, yeah, it doesn't compile and it doesn't say why. But they are improving this the moment we speak, so Remix will be available soon. You deployed this contract to Starknet Alpha first. These contracts, these here that you see from this tutorial, is deployed on Starknet Girly, which is the testnet. And yes, basically it's deployed on testnet. There's something here. Is this the same kind of workshop that happened with Uncode, like something real and one? Yeah, I mean, this one is Cairo 101, so yeah, this is the same. Could you walk through deploying to Starknet Girly? Yeah, sure. Okay, so don't know if you guys can see. Yeah. Can you see my terminal? Yep. Okay. So to deploy a smart contract, first you will need a smart contract. I'm going to take this one, which is 10 smart contracts. All right. So this smart contract has a constructor. And I'm going to remove this. All right. So it has a constructor with one argument. We know that, but we're going to ignore it. Okay, so first you have to compile the file. So I'm going to use the Starknet CLI to compile the file. And so test.cairo, and I want it to be saved in outputs in compiled JSON. And so here I will have here. And so here I have my compiled file. So here is the compiled file. It has everything it needs. And so I have my compiled file, and now I want to deploy it. So I'm going to do Starknet deploy the contract I want to deploy, which is compiled.json. And so here, okay, this deploy. This doesn't work because we have a constructor. The constructor needs one argument. So I'm going to add one argument. Let's say 0. I'm going to deploy. Okay, still doesn't work because we didn't specify the network. And so here I want to deploy it on Girly. So I'll go with alpha girl. And here it should deploy. I will have the transaction hash and the address. And once more, we can check on the here. Here the status of the transaction. This is how you deploy a simple contract. You can also use Hardhat to create a deployment script. You can use Starknet.js, you can use Starknet.py. There are a bunch of SDKs that you can use to deploy contracts. This is like the easiest way if you want to deploy quickly a smart contract. Just go with the CLI, it's really easy. All right, so let's see. When you sign the transaction, you have paid fees. Where in the contract you can ask user to pay? Okay, so fees are not paid for each smart contract. It's paid to the sequencer, so it processes your transaction. It's not like the DApp which gets the fees. The fees are paid to the sequencer. You shouldn't provide. No, you shouldn't provide the max fee per arm when you deploy contract. For now, contract deployment is still free, so you don't have to add fees. Otherwise, you wouldn't be able to deploy account contracts. This will change. I don't know when. Tom knows, so if you want to know, please tag him on Twitter. Is there an extension for Visual Studio Code? Yep, there is. Which is Cairo. There is one by StarkWare, and there's this one by Eric Lowe, which is compatible with Vim, I think. You can check on his repo. He explains how you can install it. But if you only use VS Code, this one may be sufficient. I thought we could decide on the law who would pay the fees. No, you don't decide who pay the fees. Like basically every time you want to do a transaction other than a contract deployment, you will have to pay fees. That's the thing. Alpha Girly still uses Cairo 0.8. No, Alpha Girly has been upgraded to 0.9. Fees are now mandatory. On 0.8, fees were not mandatory. You could specify just 0 as max fee, and you wouldn't pay any fees. The mainnet, though, is still on Cairo 0.8, so you still don't have to pay fees. Does that answer your question? All right, let's see if I still have. Yep, I got my points from exercise 2. By the way, the transfer function of the points of the Cairo 101 has been disabled, so you can't farm points. And so, yeah, let's go back to this. Basically, the goal here is for you to finish all the exercises. And yeah, and learn learn Cairo. I mean, start to learn Cairo while doing these exercises. Do you want me to do a third one, or do you want to do it on your own? Is there a way smart contract get the value of a specific year's tool? I'm not sure to understand the question. Are you asking if a contract can interact with another contract? Yeah, my score is 4. Yep. Do you want to talk with the mic? Maybe it will be easier. Okay. Yes, a contract can read the value from this. A contract can interact with another contract. Basically, it's done somewhere, not here. Here probably. Yeah, you have to declare the interface so your contract knows what function he can call, and then you call what function you want. You have to add the contract address of the contract you want to call, and then to specify the arguments needed by the function. So for example, let's say I want to call an ERC20, and I have declared my ERC20, the interface somewhere. I can just go with ERC20 dot balance of contract address would be like the target's address, and then owner, I think it's called like this, or account, yeah, account would be my address. And so this would return my balance for these contracts, for this ERC20 contract. The key libraries, there is obviously OpenZeppelin, OpenZeppelin Cairo contract. Please do not use the contracts from their GitHub repos, but use the one they released on Pipe. I don't know how you say it. Contracts. Please use the released version. There was like a critical vulnerability that had been found really recently that was not in the released version, so please use the released version. The key libraries, there are like a bunch of libraries built in, like with Cairo. Here in common, you have like a bunch of useful library. You have this one, which is great. I think there is, yeah, there are math stuff and everything. Key libraries really depend on what you want to do, but OpenZeppelin, definitely useful. Right, let's do it in your own, but you go over the top batches and things you need to know for Cairo versus, okay. So for Cairo, what you need to know, I would say, is that you can only deal with fields and field pointer. You can have structs, of course, but you won't have like advanced types. The memory model is write once, like you can't rewrite memory, it's immutable. So once you save something, you can't change it. You have to take care of revoked references. I think that there are some in some exercises. Yeah, I can't remember which one, but basically the implicit arguments get revoked when you have an if-else statement and you don't have the same number of instructions in the two branches. For example, if you have if 0 equals 1, whatever, and I have instruction A, instruction B, and I have else, I have instruction A. And here I end by else. The implicit arguments will get revoked because there's not the same amount of instruction and it messes with the registry, and so AP loses track of everything and it gets revoked. Can we deploy contracts from our engine? I think we can now, since factories were enabled yesterday. No, on Monday. So now you can deploy a contract from a contract. So you theoretically could deploy a contract from another contract, but not from Avant because they didn't implement it yet, I think. And because, yeah. I want to not pass in an owner param to the constructor and directly use get-color. For now, it is not possible to use get-color address in the constructor because it will just return 0 since it's the 0 address that deploys a contract. Can the smart contract be compiled on Windows or only Linux, Macs, and the you can on Windows if you manage to install the binaries, or you can use the Cairo CLI by Shard Labs. I think it's that. Yeah, there's Docker image that you can use to compile your files, and you wouldn't have to install anything except Docker. And you close share the URL, which your URL. Sorry. If we deploy ERC20 with Cairo contract, can we bridge it back to mainnet? You can build your own bridge because there is like a message, built-in messaging feature with Starknet, which means that you can send messages to L1, which will be stored in a smart contract, and you will have to consume the message on L1, which means like from your smart contract, consume the message with the arguments and use it. And you can send a message to L2. If you have a contract on L1, you can use a solidity function from Starknet core contract to send a message to L1, and this one will automatically be consumed. And to receive a message, the function has to have this decorator, L1 handler. And yeah, and this function will receive messages from it. Is this over being 254? I'm not sure to understand this question. Is this over big number 254? When do we use felt? Yes, felt pointer. If basically you use felt when you want to have like the actual value, and you use a pointer when you want the address, the memory address of the felt. I'm not sure I have an example in mind, but I'm pretty new to Starknet. Is there any roadmap prerequisites to learn things step by step? I don't know, it depends what you want to learn. If you want to learn Cairo, then you can start with Cairo 101. You can also do the only those tutorial, the Starklinks, which is inspired of Rustlinks. Only the Starklinks, this one. It's a great tool to start writing Cairo code. I want to build an application on top of it. Okay, so you will have to learn Cairo. So what I would advise you to do is to start with Cairo 101, which is this workshop. Then you can take a look at the Starklinks and do it. The beginner part is really good. And then you can move on to advanced tutorials here. Basically here you will have to customize an ERC20. Here you'll have to customize an ERC721. And here you will have to write messages, like to send messages from L1 to L2. Note that it's really slow from L2 to L1 because it has to wait for the blocks to be proven, and it takes 6 hours, I think, or 2 hours. Yeah, it takes 2 hours, so it can be quite long. So please make sure to do something while you wait for the messages to be sent. This one is to learn how to debug a smart contract with unit testing. So this can be really useful if you have a smart contract that doesn't work and you don't know why. What changes from 0.8.2 and 0.9.2? Is there any? Yeah. Okay, so this is a great question. The changes between Cairo 0.8.2 and 0.9, there is a huge difference now for smart contracts. Now, a smart contract is an instance of a class. Basically, I don't know if everyone is familiar with the classes, but basically a class is a factory, like a factory, and an instance, like for example, a class would be a car factory, and an instance of a class would be the car. And so now you have to declare your class, and when you deploy a contract, you deploy an instance of the contract class. And so now you will have to declare contract classes, and this changes deployment, since if you deploy your own contract, which has never been declared, you have to declare it. NES fees are now mandatory, and it's not a breaking change. Like everything works the same way, but you can now deploy a contract from another contract. I'm currently doing the Henry's workshop related to Solidity. Should I finish them first? Okay. You can do both at the same time. If you already know Solidity, it's a little bit easier because basically, like the hardest part of Cairo is not Cairo; it's smart contracts. It's a whole different way of coding. And if you understand smart contract, then Cairo will be easy for you. Another trap of Cairo is that it's modulo big prime, so division don't act the same way as in decimal, like in regular programming languages. When if you divide 2 by 2, it won't be 1. It would be like I don't know who can check on the playground. Here, so to improve this. Okay, it's 1. Okay, yeah, here you go. If you divide 2 by 3, then you get a weirdest number. But basically, if you this is the way it works. What does that mean? We can update. For example, ERC20. There is like the class ERC20, and if I want to deploy an ERC20, I will deploy an instance of ERC20 with my custom name. For example, if I want to call it, I don't know, Cairo 101, I will deploy an instance which with the name Cairo 101, a custom supply, and whatever parameters it needs. Don't know if it's clearer. Can we do mod operator natively? I think there is a library for that. Let me check. In here. I don't see it here, but it probably exists somewhere. How do you keep up to date with the what do you mean? How do you keep up to date with which version of which tool? Basically use the latest version and hope for the best. For now, I don't think that tools are yet compatible with Cairo 0.9.0, but it will soon be. I don't have dates, but I'm pretty sure they will soon be compatible. In any resources you recommend to learn about smart contracts in general? I don't have special resources, but if you like the principle of, I don't know, having exercises that correct themselves automatically with and grant you points with the ERC20s. Henri has Solidity tutorials, so you can just go on his repo on his GitHub, and you can check. Yeah. So he has someone sent the link. You can check, and he has a bunch of exercises, which are pretty good. You will, like in one of the tutorials, you will have to do a flash loan and everything. So really interesting. You'll see a lot of things. Could you talk through non-deterministic jumps and how they apply if at all to Cairo written? I think that non-deterministic jumps is just a fancy name for if statements. Check the doc, but I really think yeah, non-deterministic jumps. The jump instruction that may or may not be executed according to the prover's decision. Yeah, so basically it's just like an if statement. You can write like really low level Cairo if you like difficulty, but you can also use like the higher level syntax, which does not include like jumps or whatever. Don't know if that answers your question, Noah. I guess yes. Yeah. Okay, so wasn't sure if it was something. No. It's not. It's low level Cairo, and you will probably never see it on Starknet except if you write low level. All right. So go back to the ERC. 2 seconds. Cool, but if I want to do changes to 101 coin instance of ERC 20 after deploying, is it possible to update that same instance, or do we need to deploy another instance? You'll have to redeploy it. You can't update a function. What you can do is have a proxy pattern, like most of the wallets do. Let's go on. Let's, for example, their contract here. Basically, they have their implementation of the account contracts, which is like a big contract. They deploy it once, and then for every user, will just deploy a proxy to it. So you will deploy this contract, which is way smaller, and basically it just delegates call to the previous contract we saw, to this contract. And so delegate call, basically what it does is here, delegate this one. Okay. So delegate call this function. Delegate call will just use like the code from this contract and execute it like here. So if I delegate call from this execute to this one, it will use this code. So you can like have an upgradable contract. Here you can like this proxy will point to a contract address, and the contract address will be this one. And so if you want to upgrade it, you deploy another contract, like your upgraded contract. For example, here, if you want to remove this, you deploy another contract which doesn't have this line, and you change the address. This one delegates to call to, and it will delegate call to the new contract, and there won't be like this line, but it's fairly advanced, and yeah, it's up to you and your dApp design. Let's say you wanted to have a string stored in your contract that user can set. How do you implement that with felt? Good question. So let's do it. Let's remove this. Let's remove anything except that and that. And okay, so I want to store a string. So as I said, Cairo only deals with files. So if you want to convert to save a string, you'll have to convert it to files. So what you can do is go in Python and use this from bytes, which will be your value. So here, let's say hello. Byte order, if you want big endian or little endian. I want big here, here. So this is hello in felt. And now what you want to do is store it on your contract. So you want to storage var. So this is a storage var. You have the decorator. The name will be, I don't know, string. The key, nothing. Oh, the key, yeah, nothing. And here it returns a value. So it returns the word, which is a felt. So here you have your storage variable, and now you have to create the setter, which is an external function, which we call set word. Here you have the implicit arguments. Basically, just copy paste them. Every function doesn't need all of them, but most of the time it does, and so you have to put them everywhere. So this function set word takes a new word as parameter, which is a felt. Typing is optional, but I like to type everything so it's clearer. And here it will return nothing. So here and here. In Cairo, every function has to have a return statement. Yeah. Oh, no. And so here, what we want to do is store the new string. So we have to do string dot write, and we want to write our new word in it, and that's it. And here, always try to compile it. And yeah, you have to have a return at the end of the function. And every return has to be a tuple, so even if you return nothing, you have to add like the empty parentheses. And so here it compiles. We can deploy it. Let's deploy it. So this doesn't take any inputs. All right. And so here we're just going to wait. Let's deploy. Do I still need to maintain the storage arrangement when upgrading the contract? When you delegate call to a contract, if your new contract implements a new storage variable, it will be created on your proxy contract. So you don't really have to maintain the storage arrangement. It's not like in Solidity. Why did we choose Cairo while there were other programming language available for writing smart contracts? Okay, so Cairo basically is just here because it's super easy to prove it, and so it facilitates the prover's work. So here, these are like instructions which are failed, so it's super easy to convert it to a polynomial and then prove it. Yeah, that's the main advantage of Cairo. How did you create the storage? Oh yeah, so I have like snippets. Yeah, I have snippets where basically you can just say what you want, and then it will automatically create the code. They're available on the Starknet EDU GitHub somewhere. I did not update them recently, but It should be here. Cairo snippets, yeah. They're here. You can copy paste them also. Feel free also to contribute to them. Like if you want to add some, please do a pull request. If you want to add more and you have the idea but you don't know how, please open an issue. Really, it really helps. Yeah, there's a limit on short strings. It's 31 characters. More than that, if you want to store them in your smart contract, you will have to do a mapping, which will have like the index and the word. And here you will have to add the index right here. And here you'll have to write at the index, you'll write the new word. Can we use a local testnet? Yes, you can. Basically, the local testnet is called the Devnet. It's done by Shard Labs, which is a wrapper of the testing functions provided in the Cairo package. You can check. There is also a Docker container, like a Docker image, but you can also have binaries. Devnet here, yep. This is Devnet done by Shard Labs. It's quite slow, but they're working on it, so it's a little bit faster. But at some point, I'm pretty sure it will be usable, like really usable. Is there also a linter for Cairo? There is. It's a basic linter, which is called Amarna here. It's a static analysis tool. Yeah. I don't know if I have it installed somewhere, but maybe I can show you. Yeah, I have it. Let's try it. I haven't updated it for a long time, so maybe it's outdated, but let's check. No, it's not outdated. Okay, so analyze the current project from the current user. Okay, so here, let's paste this. Okay, and then in Visual Studio Code, I have this. Right. Okay, maybe I should add some more code so it has something to analyze. Maybe I have an example here. In the test. Yeah, let's try this one. Here, and here. How does it work? I managed to make it work some one time, so it should work. But anyway, this exists. It works. Yeah, you'll figure it on your own. I have tried it. It works. Now let's go back to the string saver. Here, let's go here. Right contracts. And here you can just set your word. Obviously, I didn't do a view, so I can't see the value, but you can set it here. Yeah. And then it will just be saved on your contract. I should have done a view. Yeah. Nope. Let's do it here. View. It takes nothing. It returns res. And here we're gonna read the string. So let's raise. Here I put the res between parentheses because it will be like the return value of a function. And as I said, every return value in Cairo is a tuple. So you have to unpack the tuple. And so here I unpack it here, and then I return it. And then I can compile it here. String that should have, and it deploys, and it will be usable after that. I don't know if you guys have any more questions. Give me a sec. I'm just going to paste the link. Yeah. Oh, here's Amarna. Okay, so where can we learn about the proxy pattern? Is there resources or just by example that you shared earlier? It's probably written somewhere in the doc. Yeah. You can go here and delegate. This. Yeah. Yeah. Here you can have like, yeah, now it's called library calls because it calls a class, not an instance. So now you would probably have to specify the class hash of the contracts you want to delegate the goal to. Before you had to enter the address because you would delegate call to an instance of to a deployed contract. Now you deploy the call to a contract class. So now if we go here on Cairo v9 contracts agent accounts, it's called library call and they call to the contract hash. I'll send also the link to this library call. Yeah. Here you can see, and you can also check various implementations. It gives a good idea on how it works. Does the size of a field element is 248 bits? No, it's 252. Yeah. Yes, probably a good idea. The value of a field is like 2 to the power 251 plus 17 times 2 to, I can't remember what. But the value is probably written somewhere here. Yeah, so it's a 252-bit number, and the value is not written here. Oh, it's not written here, but it's written somewhere, and you can probably find it. And what's funny is that since it's modulo p, there's no negative number, but it can. But as it says here, what's between p and p divided by 2 is considered positive, and what's over p divided by 2 is can be considered negative. There is a function called sign somewhere where you can sign a failed. Can we have a true division modulo if we can't do it in kind of trying to convert decimal to... I'm not sure I understand the question. How can we have a true... there is like there's a function called divide something. Cairo common, and here inside the control. So this is a division with, like here it does that basically. This is the same, but it returns a sign failed, so a negative or positive. Yeah, yeah, and that's probably how we can do it. Are there any significant advantages to working with Cairo using Python versus JavaScript? Yeah, that's a good question. For now, the only advantage is that testing time is really faster with Python than with JavaScript, because with JavaScript, you have to use the Starknet Devnet, which adds a small layer on the testing framework, the Python testing framework, which makes it really slow. So there is this advantage, but this will disappear soon, I hope, because everything has to be upgraded. Does that answer your question? What are conventional ways to convert fields into string or hex? I think there's a website. This one is to follow your progression. It's nice UI. Yeah. Oh, yeah, I have 2 points. So yeah. But there's like I think there's a website somewhere that you can find, which allows you to convert. But what I like to do is do it in plain Python because it's really easy. Here you can do that to convert string to int and hex to int. You just int your hex like this. And you get your conversion, so it's really easy. You want a link to the site to follow your progression or to convert fields? Because the one to convert to fields, I don't have the link to it, but it's probably somewhere in Discord. Okay. Starknet Devnet can be used with light mode inside Python. Yeah. If you use Python, you don't really need the Starknet Devnet, so there's no real point. But if you use JavaScript, yes, you can use the light mode, which basically disables the computation of the deployment transaction hash and some other hashes, because Peterson hash is really slow. And so if you can avoid computing some hashes, then it makes everything faster. But yes, you can use the light mode. Shard Labs, I did a great documentation here on what it really does. Light mode here. Basically, they explain what it does. All right, any more question?
Wonderful. I think this was a very helpful session for everyone. I think, Lucas, you were wizard trying to help everyone. And I think for the last hour, we asked so many questions, and it seems like we learned a lot. And thank you everyone for sticking around and asking awesome questions. And we'll be releasing Google Form attendance sheet and the Discord. So for everyone who listened, if you want to participate on the hackathon in mid-August, you should be listening, filling out 7 out of 11 sessions that we're going to have throughout this 2 months. So yeah, and thank you again for your wonderful time and your wisdom.
Thanks for your invitation, and thanks everyone for listening and coming.
Wonderful. Yeah, let's start building, and everyone have a great day and night. Yeah, thank you for your time, and we'll see you next week on Wednesday, 1 p.m. Eastern time again. Bye-bye.
Bye.